guys, this is a quick video to respond to a question which a student left in the comment section. This is on chapter 4.4, Principle of Moments. So remember what is the principle of moments? If we have a point here and we've got a force acting there, and remember this is 4.4, we're not dealing with couples here, we're just dealing with a force and we're trying to find the moment of that force. Remember, let's change the angle of this force like that, right? Remember, the first thing that we want to do if we want to find a moment is we need the force, and we need in scalar form we need this perpendicular distance, right? Moment equals force times distance. But remember that if it's not easy to find that perpendicular distance, maybe even impossible, what do? We break this force up into x and y. And so the principle of moments states that the moment due to this force, the moment of that force about that point, the moment of that force about that point is equal to the sum of the moments of the components of the force. So that's Fx, that's Fy. So F times d, this force times d, is equal to the sum of all the, I don't know how we can do this, the sum of all the FDs. Okay? But these F's and D's are the forces of the components of that force. These are the components of the force, right? So again, the moment due to this force about that point is equal to the sum of the moments of the components. So if I calculate the moment due to this component and I add it to the moment due to that component, it's exactly the same. So why do we want the principle of moments? Again, because if it's very difficult to find d, it might be a lot easier to find the d for each of those components. Okay, so that's just the one thing. Now, the question was, I still struggle to understand how to find the direction of the components of the force. So I'm not sure if that's really an accurate statement there. I think he's talking more about the moment. How do we tell if the force is acting along the positive anticlockwise direction or the negative, the clockwise direction? Okay, so let's take this again. There's a point, and say now we have this force there. Okay, how do we know? So this force is, say there's a body here, okay, and this force is acting there. How do we know whether that force will cause a clockwise or an anti-clockwise moment? Well, this is where you need to be able to draw the line of action. If you can't tell what's happening, draw the line of action. Okay, there's my line of action. And what have we learned in this course is that because we're working with a rigid body, we can apply this force anywhere along the line of action and it will have the same effect. So if I take this force vector and I put it over here, it's exactly the same force, magnitude, everything, and I put it there, what would you say, what kind of moment does that cause? Does it cause a clockwise or does it cause an anti-clockwise moment? Well, you can see that it would cause an anti-clockwise moment. So my initial suggestion is take the arrow, draw the line of action, and bring it towards the point of rotation. Okay? So bring the force vector towards the point of rotation. Don't leave it so far away. So here's some examples. Okay, so there's a force. Okay, there's not much difference here if you try to bring it closer, right? What about this one? See, that force is quite far away from there, but we don't really know what's happening. So my suggestion always is bring it, draw the line of action, draw that line of action and bring the force in this over here. Then you might be able to see more clearly what the effect that force has about that point. In this case, even though we're going to break this up in this example into its x and y, then we know just by drawing the line of action. Let me get a ruler. So if I put a ruler there, right, and I draw, I'm not going to draw in my textbook. These things are very expensive. Okay, but can you see roughly that if we bring it here and we bring the force over here, can you see, and it's downwards, can you see that it would cause a clockwise rotation? Okay, so that is kind of an initial idea that I'd like to give you regarding how to determine whether it's clockwise or anti-clockwise. Another way is bring that vector down there and then draw a kind of a beam attached to that vector. And ask yourself, if that's my point of rotation and I'm applying a force upward on that beam, is it going to cause that beam to go clockwise or anti-clockwise? Okay? So let's have a look at some of these examples here. What is that going to cause? That 500 Newton, about point O, that's going to cause a anti-clockwise rotation, right? Because if you take a beam over here, you bring this force down here, and you apply it up, it's going to cause this beam to go in an anti-clockwise direction. Okay? Similarly, this example here, we're going to break this up into its x and y. The one thing that I want to mention to you, which is very, very, very important, is you're going to get a 50, and you're going to get a component here in the x direction and a component in the y direction. Now, don't get confused between making this a minus component and that a minus, because they're going in the minus y and minus x. My advice to you is leave the forces in as positive. And then only once you've determined the direction of the moment do you give the moment a negative or a positive direction. Okay? So this one is going to be in that direction there, right? In that direction. So if I bring that force all the way there, right? That's going in the direction of the pen. What is the direction about the point O? Can you see it wants to go anti-clockwise? There, it wants to go anti-clockwise. So we have that force vector over there, and it always goes towards the point of rotation. Rotates around it. Doesn't go that way. Doesn't go that way. It goes that way. What about that one there? Well, if we've got the force going down like that, can you see you go towards the point of rotation? It wants to cause a clockwise rotation. Okay? So I'm not sure if this has helped. I hope so. Perhaps you could just give me some feedback whether you require some more assistance regarding finding the direction. Okay, cheers.